Okay, so I guess we all join and just check for voice quality. Is everything good? Voice quality. Is everything good? Yeah, it does look like good. So I'm pretty sure you must be thrilled to join if somebody joined. Uh, there's no one that joined so far, so anyways, we starting 12:15, right? That's what I posted, so let's wait for. To be very frank, there won't be anyone joining because I never inform anyone that I am doing live stream where I'm trying to learn because I think I should share with the people that I do live stream here and people can learn about the Postgres alongside me as I learn. That's gonna be really hardcore value. So anyways, today is day 9, totally about table constraint and modification. As of yesterday, we were not able to cover in time. So today we won't delve much into recaps. We will just delve into the recap from yesterday, not day before yesterday, because we have somewhere cover those things multiple times, like what is SQL, what is database, what is schema, what is RDBMS, and few more things here and there. So we are not going to do that. We will simply delve into the things that were pending from yesterday. So I'm just waiting for my PG admin to logs, but meanwhile we will simply go and open our GitHub. So if you are new in this channel and you started watching this live, simply go to this YouTube channel, Code for Coin. Make sure you subscribe. This one I'm not subscribing because this is one of my own channel. I want to grow my channel organically, so I'm not going to use any of my other email IDs. If you click here, if you want to read the description, you can read it. But the one that is really important for you is two of the email IDs as of now. But in the future, there will be useful. But first, simply make sure you subscribe my channel or our channel because I'm going to keep you updated with the live session and the videos we are constantly uploading. Second one is go to my LinkedIn account, just follow me. That's second thing. A third is very important is your GitHub. Because most of our resources are available here. Right now we are working on the repository SQL, then we will work on Python, then AWS, then data structure, then algorithm, and ML and AI as well. So let's quickly go to data structure, go to the directory number 4, that is equals 0 to hero. Just leave the 000, start with the chapter 1, chapter 2, chapter 3, chapter 4, and every chapter is very thoroughly created using the knowledge and AI. So you get the best out of the resources. If I just open it for time being for our convenience, let me keep it here on second one. Mm. So you see here, you will find first the request for buy me coffee in case you are generous enough and find this content useful and you want me to keep on working on this. You can support this journey through donation or like not exactly donation, but buying me a coffee will do the favor. So like see, very crisp information was written here, then a structure, what is structure query, then language and a brief history. And we are pretty much done with this thing. So if you want to find the link again for the YouTube, GitHub, and LinkedIn is available here. Again, buy me coffee's link is here, and very quick references. I keep it here, so you guys have understanding what you are learning and what were the interesting thing. So in this one, you will find very crisp notes. plus exercises as well. And for the exercises, I have created a very separate directory that I will be using in my own book that I have created. So it's gonna be really, really, really interesting if you are here and you want to learn more. Hmm, I don't know why it's happening before coming this one. I was so excited. I was really good, and all of a sudden I started yawning. So I'm not going to waste much time into it. Let's see if somebody joined. No, nope. So it's fine. So let's quickly go into the day number uh 7, because day number 8 I haven't created because that's something we need to continue. So this is the default values. We talk in very detail about what is default value that is being used, what is identity column, and what is your generated column, and why identity column came into existence, what is default value that we use, everything we discuss, and all the scenarios as well. So if you haven't watched the live from day number 8, go and watch. Today we're gonna continue from the constraint. So we will quickly go into the data definition, and then we will quickly start with the constraint. So there are that we're gonna talk. Yesterday we covered first two, and now we are supposed to cover the remaining four. But I will quickly start with the constraint itself. What exactly constraint it? I won't take much time. So remember, constraint is really important. Constraints. Okay. So thing is, you understand one thing, that relational database management system is your building manager who makes sure that the operation of the building move properly or smoothly. That building itself, where all the people, all the object, all the things are living, is your place of living, right? And similarly, it is for us, it's a database. That building is the database. Every floor that we segregated this database or the building based on certain theme, based on certain requirement. This is nothing but called schema. Perfect. And each floor then is being designed based on that theme and requirement, or that design means like creating multiple rooms, the pantry house or pantry room, or multiple rooms, kitchen, bathroom, and everything. That designing within that schema is nothing but your tables where we store the data. Correct. This was the basic analogy that we were using for our understanding about the mechanism of a database, table, and RDBs, right? And schema as well. But what is constraint? So I told you that even if you design everything, the table and everything, the actual information when comes in, actual information that comes from the real world, okay, it can be anything. When I say anything, it can be either a good information and it can be a bad information. When I say good and bad, it doesn't mean its value. It means in response or in corresponding to our table. Does it have validity? Is it valid data? It is good data we store in our storage or in our table. So for the table, I told you table in SQL is a collection of similar entities with same attribute, characteristic, or information, right? So if you look as the table structure is row and then column, each row represent a collection of information about an entity E1. Say row number 2 is a collection of information about another entity E2, and so on. But what you find that the column is a static, that the column that E1 share for number 1 is actually shared with the E2 as well. Similarly, all this one. So whatever the information I'm trying to store for E1, I'm similarly storing for E2 as well, right? And that's why it is called a collection of similar entities with same characteristics or same information that we store in our table, right? That is something we define, we structure that what so so now how this table is created. This table is created using this command create, create, create table, then table name, brackets, then column name, column data type, right? So this is a blueprint that tells my relational database management system that you need to create a table where the entities I'm gonna store will have one, two, three, four, whatever the column you have defined, this number of attributes or information, and the corresponding data type or the value for this information should be integer, text, boolean, whatever you are defining, right? That means if the first one, the first characteristic of that entity is name, so that means the entity that is coming, I need to have its name as information in the first column value for that entity. That means we define the data type text. That means you cannot give his name as 123, right? You have to give him the name that is text or a string, right? So first rule that itself define what kind of information gonna store for that corresponding attribute or column is defined by data type. So these rules are nothing but constraints that ensure data integrity. Data integrity, but whose of table, the of that table, right? So this ensure that the value that you are trying to store, the information about the entity you are trying to store in that table is legit, valid, and compile or compliance with the actual legit value that need to be stored. Okay. But sometimes this data type is not enough. I give you an example that we created one schema for student, your personal, right, data, in which we created one STUD, student personal table, right? We created this one. Here we are collecting information about the students from different university, and what kind of information get from each entity. First one is student name that we are gonna collect as form of text or string. That means if somebody is giving numerical value like 2.1, 3.1, or integer like 1, 2, -8, -30, 1000, they gonna fail, because based on the information that we need to receive for a student, for this student name, it has to be text or a string, right? Second one was student age. Now it is integer. That means you cannot give a string name, right? If you give a numeric name number, it might have failed, but Postgres internally convert numeric to integer by doing roundup. So that was supposed to fail, it doesn't fail because the implicit conversion of Postgres take care of that one. It has to be failed because the data type that you are giving information in is not matching with the data type of the one you have defined for the table. But the Postgres knows sometimes people make mistake, and they created one logic where automatically the numeric got converted into integer, or integer got converted into numeric by rounding off. Okay. Third was student address. Again, it was text. And finally, university ID. That was integer. Okay. Second thing, I told you that despite the fact that student age is integer, that means it should be integer value or integral value, that is 0, 1, 2, 3, -10, -100, like anything. But can the age be in negative? Can a student P of A0 that is born, he is not like born properly and he is joining the university. Is it possible? No. That means data type only provide the rule or constraint about the data nature they're gonna accept. They will accept. But there is a possibility that we need more rules, more constraint dynamically or based on our requirement to be more precise, to be more data, more to increase the integrity of the data or to increase the legitness of that data in that table, right? So we can make sure that the student age is always greater than equals to 18 and always less than equals to 15 years old, right? That means apart from the constraint that the information of data A should be integer, it should always be greater than 18 and less than 50. So how to add this constraint in this table? So you remember we defined the column as a student age, and then we define the nature of the data it is going to store is integer. Now we can add the constraint. So doing the constraint, you can do it in two ways. I'm leaving it blank. Time being is empty, right? It's empty, just take it. And you write here, uh, check student age greater than equals to 18 and student age less than equals to 50. If you do that, what gonna happen whenever a record for a student will come with this name, age, address, and university IDs, they will first check if the nature of the data they are providing or the nature of information they are providing for the corresponding columns is it matching or not. So first one is name, is it text, right? Age, integer, right? Address, text, right? University ID, integer, right? So the first test is passed. Do we have other constraint after this? Initially it was no, they inserted, but later they found out few students tried to prank the university by putting the 8 as 0 or negative 100 or 10,000 or something. Because that data doesn't make sense because age cannot exceed from this limit. So what they did, they put condition that before they enter, after checking the information nature is matching with the corresponding column or not. If does, we're gonna move to the second. He will check for other checks or other constraint. So they find out for a student age, they put a constraint where age has to be checked and measure. It should be in between 18 and 50 included both. If it is, then only the data is legit. And now all the constraint is being checked. The record or the information about that student compile with compile it follow all the rules that is defined for the table and he's gonna insert into the table. That's how to. In case it failed, it will throw an error that the check failed here. So yesterday, if you saw our code, you find that if we write like this and a student's uh, failed, so it generally write like constraint a student age check again failed. So it automatically give a name to the constraint you are putting in, right? It does automatically, but you can control it by writing constraint and then constraint name. So next time this will be replaced by the name you have given in the query. And this is something we already did it. Let me check. It should be here. Dude, I think it's not saved. Oh my god. Oh, I should have saved it. Dude. How come it is not saved? Anyways, before we move, let me ask if someone has any questions, any doubt or anything. Okay, nobody has anything. So let's quickly do it, okay, for our convenience. So I'm creating create create a table employees. Okay, because table is a collection of similar entities. That means there will possibly entities one and more, but usually more. So we keep the table name as plural and the column attribute name as singular because it belongs to single entity or single information about an object or entity, right? So create an object or create a table employee, and I'm closing this one. So I'm putting only one thing right now is ID. Uh, or let's put it like student. Okay, and since I'm not defining any schema, it will go to the floor. That is the basic ground floor, right, of the building database. That is your public schema, right? So here I'm going, or I can, or you can define by yourself as public or this one. Now what we are trying to see through this one is to check the constraint. So student, first one we have column or the attribute or the information about the student we're gonna collect is the name in the form of text we're gonna receive. Then is your age in the form of integer we're gonna receive. Third one was your address we're gonna receive in the form of text, and then ultimately university ID that we're gonna receive again in the form of ID integer. Okay. If my thing is like this, then I can simply insert into uh public dot student. Okay, values. So since I am not defining any of the column here, that means I'm going to take all the column in the same sequence. So value that I'm going to insert should be in the same format. First one is name, suppose is Nitin. Age 20. Address Nitin. Home. Address is home. And university IDs is one. Okay. And I will create here drop table if exists public in the public schema, and table is a student. So if I execute this one, it does insert one without any problem, right? Notice student does not exist. Table student, public student. Select all one from student, public dot student, right? So let's quickly run it, and we got our value. That means data is storing. Okay. But the biggest problem here, this is the good one. Let's go for a bad one. Robert is a bit mischievous guy. He put his age as minus 21. Do you think someone age can be negative? Answer is no. But it does store it because our SQL work based on the instruction we give. That's the programming. We program it. It follow a flow, and that means we need to define all the worldly or world based rule or the logic into it. That means we need to always check for the address that it always stand out. So let's write it down. Check age should be greater than equals to 18, and age should be less than equals to 50. That's my logic. Let's run it again. Now it threw an error that age is greater than 18 and this one is failing, and it should be failing at number 11, but does it give me the line number 11? Error line number 5. What happened? Is it failing? No, there's an error with the syntax. So age, this one check. Syntax error, dude. Age, price. Do we need to put into brackets or something? Check. Like I'm giving it as a function. If it is, then I will learn something new, dude. Yeah, it does. It does. It does. It does happen. Yeah, 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 yeah. So if I'm doing it, okay. So one thing that we learned here is first thing, learning that learning one for the day. Check as check is a constraint function. That means you put condition inside the calling function parenthesis. Yes. This is a really interesting route. Now I will always remember that check is a constraint function. So you need to put into the parenthesis to make sure you have the value. But if I run it, it failed again, right? Because what it say, new row for relation student violates check constraint. And see what is the constraint name you put? It's student age check. If student is your table name, age is your attribute characteristic of the element or entity I'm going to store, and then check is that constraint function that failed. Okay, but sometimes you want to name it because you feel like naming it. So you put like I'm defining a constraint here, and the constraint name is your constraint table name student, then the attribute on which I'm putting age, and what kind of constraint I'm putting check. So it's a student age check. Now it should be cons for your constraint. Now see the name change. That means if you're not defining a constraint name, system gonna automatically put it, and the structure will be table name, entity information or column, and then whatever the constraint it failed into. So this is how we ensure that the data quality is maintained or your table integrity is maintained at a given point of time. Now is the store problem. What about 50.00001? Now you see this one. I told you if you put numeric value, it's gonna round off. So it before even you process this entire system, it will round it to 50 and then it will do the things. That's really interesting. So you can ask someone if it pass or fail. This gonna be interesting. This gonna be a really interesting question. It does pass, but what about four? Pass. What about five? It should fail here. After five, it failed. Yep, that was right. So if it's four, then whatever value comes, it doesn't matter. Yep, I knew it. After four, it's gonna. It's so interesting, dude. What about so it's 17.9 or five? Dude, see, 17.5, it become 18 and then it was inserted. So this is really, really interesting if you ask someone on this thing for a student or basic student, right? So we understood what is check, how it work. We can quickly move to other thing. Before I move, do we have someone join here? Nope. Not even a single soul. Why is going so slow? Okay, let's quickly go to here. A check constraint is the most generic constraint type. It allows you to specify that the value in a certain column must satisfy a Boolean truth value expression. For instance, you require a positive product price. You could use, yep. So you can do it anyway. So it's not a big deal. We learn about putting a name to that constraint check. Is done. Product integer first one, or even check this one. Yeah, you can simply define it in an individual way like this. Rather than attaching it to a column, you can do it in a separate. Uh, that was check about. So check is the condition you check before inserting a value inside an attribute of entity or a column of a table. You simply check it. If it failed, it failed. Second constraint is not null that we defined it yesterday itself. Not null in case you receive the information about an entity from somewhere and you realize few of the entries is missing. It's not empty, it is missing. Okay, missing is called null. And you put it as an integer as you put a constraint that these entities never ever could have empty values for this corresponding attributes, then if they does have, that means they're gonna fail. They are not allowed to insert. So it's a barricade that for a certain attribute of the entity you are trying to put a values, it should always occupy some values. It cannot be empty at all. If it does, it is not allowed to enter. So not null is that constraint of filtering out the data, dropping the data where the entity does not have or have the void or empty value for the particular corresponding attributes. And as simple as not null. But the thing that I want to know, even if you like put the not null alongside with the column and column data type, you can define it separately, like not null and then the column name. It just is here column name, column data type, and then not null. Here it is not null column type. That's it. But again, I will check one thing. And this is good. I will put, see, at given point of time, I told you that if I'm putting information about a person as a student into this table, what define a student? Our students define who is enrolled in a university. That means at given point of time, the university ID of a student cannot be empty at given point of time. If it is, that means he's not a student. He's not eligible to attend this one. So we will drop all the record, all the information somebody is providing, or providing for some student. It will drop if they doesn't have university ID date. That means I need to drop all the record that's coming into this table in this storage if they don't have university ID or the university ID is empty not. You need to drop it. Right now it will execute because we have both IDs. But what will happen if I put empty value? That means we don't have this one. Now it started throwing an error that university ID null value in a column university ID of a relation student while is not null constraint fail failing row contain Robert this one. So it gave me that understanding. If you look at this one, there is no constraint name because here it is keywords. Null and not null are the keyword or keyword combination, but constraint was the constraint check. It was a function. Yes. Can I write it same way that I write for this one? I think I just should be no constraint uni university ID, and it will fail. Null error. Let me put this one and execute. Okay, it is passing. That means I can put, because not null is also constraint. You can put a name, but does it show me that name? Null value in column university ID of a relation student violate not null constraint. Failing row contain this one. So it does not use the name. So even if you check here, uni ID, we don't have right here. No. So even if you write this, it's all right. And if you don't write it, it's also right. Because not null is very generic. Okay. So that's why you don't put not null, not null. Okay. So one thing that I like about this one, that you can have combination of constraint. Since here not, what will happen if I put as 2? And now I'm putting my age as null. There is no nut null, right? Now let's see, will it insert or not? Bypass. See, it bypass that logic. It bypass this logic of null. Okay. So now let's check this. What happened when we come? Because ultimately, what happened? This null is being compared. That null is greater than or empty. Or emptiness is greater than equals to 18, and emptiness is less than equals to 50. My check should pass when hold or get the value true boolean from the expression, but we were passing null as a value, that is emptiness as a value. Technically it should fail, right? How? Select again, we're gonna check null greater than equals to 18 and null less than equals to 50. That's the one. I want to execute this query, and it does return null. It return null for a column boolean. Check null. For check null, it is getting null, but it is bypassing it. That means check will pass under two condition. Under two conditions gonna pass. First one, if it gives you a true value in the expression, it will pass. Second, if it is giving you null values again, it will pass. Okay. So we understood for check, it will pass in either if expression will give true value or expression gives you null or empty value, check will pass. And this should not happen. That means we need to barricade or filter out this kind of record. So check pass null values, but technically should not pass. So we're gonna do one more thing. We're gonna pass not null. Age is not null, and then it gonna check not null. If it's not null, then only it will check for the constraint. Let's run it. So it failed. Null value error. So if I remove this one, it gonna pass. But now what happened? We put one more filter. We apply one more condition. We apply one more filter. We apply one more rule that this table or this structure will hold data where each entity's age is not empty. It should have value in it. And what kind of value it can hold? It can hold the data nature as integer. And then we will check the constraint that the value is greater than equals to 18 and less than equals to this one. But again, we can do one more thing. You remember, we can do right here and age or not null age or age or null. What happened? It bypass. But age and age is not null. Yep. See. So new row for relation student violate check constraint this one failed null value. It is failing check condition. So inside the check itself, we put three conditions. First one, age should be greater than 18. Age second, age should be less than 18. And lastly, age is not null. That we put into this one. But everything we are putting into one column, it doesn't make sense. So why don't we just cut this out and add it as a separate here and put it constraints. Let's first change it to 19 to check if it is running. It is indeed running and null. So now it is failing. So what I did, you saw that I created segregation in the table structure, table definition, where first portion inside this parenthesis belongs to column and column type that defines what kind of data nature should have that it can be stored in this column. Second portion, I'm defining the constraint. Right now, the constraint was simple. It belongs to one column, so it was not a big deal. But they are constrained when you need to create the rule based on two or more or multiple columns together. That time, if you associate that constraint with the same one, it doesn't make sense. You have to put it into a separate segment like this because it will improve your visibility, it will improve your understanding of how much of constraint and rule you are putting into this table. So it's good to like segregate the things. You define the structure. This is a structure, how my table gonna look like, what kind of data nature I'm expecting for the corresponding column. Here you define all the rules and regulation you are putting into this one. Okay. And if you feel like, okay, I don't want, because there's a possibility that now this is the age, right? But you felt like name cannot be empty as well. Oh, sorry, university ID. Let's just start with the name. Name should also not be empty at all, right? That should be a constraint. So you will again write like constraint cons for name for student, then name, and then you're putting for null check. Right? So not not null. That you're checking. And then you can put like check. You can put check not null. Everybody. And you will put check. Then check is a constraint function. Then you will write what is it? Name is not null. right? And here I'm putting 19. It should execute properly, but someday I feel like, okay, Robert, you can go. I'm putting null here. It will fail here. Do you think it will pass or not? It will pass because it's an empty string. It is not null. It's an empty string. That means there is string. There's a value that is coming. It doesn't have any character so far. Okay. But this one means this means empty. That's wrong. We cannot accept empty. But if you feel like for simple name, we create one constraint and constraint name and this one, it look really, really cumbersome. And that was the reason what we did is to put constraint here, but the constraint not null, we keep it alongside this one because it look very easy to see on digest than creating a separate below. It will automatically tell that firstly what should be the column name or the characteristic or attribute or the information about the entity we're gonna receive. Then second is going to tell what kind of data nature we are expecting. And third is like whether we are expecting empty value or we cannot expect like empty value. That's why not null they keep it alongside this one. It improve the visibility. Okay. So now if I run it, it will fail again. But if I replace with row word, now it won't fail. For university ID, again, I put now again I told you for not null you can put like constraint and constraint name, but this is not being used like the name they never use it, so you can simply keep it not null. And that's why they're keeping it alongside this one. It makes sense to me as well. So we are good with null and not null, and by default is null means it allow a character to hold null by default. And that's why null and not null, we keep it alongside with this structure because it makes more sense to me. The not null constraint has an inverse the null constraint. That means it will come by default. So if you look here, this or this both means same. That means null is allowed. Not null means not null. That means null is not allowed. If you put this or not is same. If you put it here, same. If not put same. But why we never keep it? Because in a column that you see is have only 4 or 5 columns for an entity student. But when we work with IT, I saw a table forming like 200 column and it cannot be segregated because one column have a relationship with the other. If you keep it in separate table, it will increase the length of queries you are going to write for joins and the stuff that's gonna come alongside as we proceed. So avoid those kind of a thing. We keep everything in the same table. It is against the rule, but sometimes you need to compromise on simplicity and more of data visibility than just creating more uh, individual tables and then forming relationship which generally gonna increase the complexity of the project. The best example of this one is to understand that for higher people, top-notch people of a company, they need dashboard, they need entire data altogether. They don't want everything segregated. They want everything in a place where they can check which country have how much sale, how much money they are burning, how much they are investing, how much they are getting out of that. All this thing they want in a single dashboard, but technically if you look at it is from very different perspective. One can be your location, one can be your order, one can be your total revenue, one total investment, one total sales, one total opportunities. This can be individual tables, but the higher authorities they need everything together, that it makes sense from end to end perspective and they understand which particular country and the state is doing well, which are not. Why? And then they work on those whys. So rule and regulation is something that we create for our convenience, and it will shift the dynamics, it will shift based on our requirement as well. So we are done with this one from yesterday. It's already one. Now we will start with unique constraint. So today we're gonna have unique primary key, foreign key, and exclusion. We'll quickly go unique key. Unique constraint ensure that the data contained in a column or a group of column is unique among all the column in the table. Okay. When written as a column constraint as. So this is also constraint, but the check was a function constraint. We put the parenthesis, but here now I think of now that I think of kept it like this, right? Why don't I put this thing, copy this thing, add to the age, and instead of this, and check this. It failed. It failed. So it is not working. I thought it might work. Constrain this one. Check age is greater than and okay. Everything does look good. So now let's replace it. 16. Uh, yep, you cannot do anything. You cannot. I thought it would be fun if we do that. Robert. We cannot do it. I thought like it will be fun if we can put two constraint without parentheses, but we cannot. So unique. So unique. You see, not null. It worked for that one, right? Put a constraint here and then let's say put not null name. It will work, right? It worked. How about not null parenthesis? It will work. No, it doesn't. How about check name is not null failed, but if I put in the bracket, it is passing, right? Indeed. So not null we need we don't put brackets, but for unique we are putting bracket, for check we are putting bracket. Why? Has written like this. Mhm. When written as table constraint to define a unique constraint for a group, write it A table constraint with a column name. Hmm. So if I compare anything with null, it always act as a true because it's empty. For emptiness is pass all the logics. Uh, so all the constraint can be followed with the same structure as constraint name, and then constraint. So unique, it can be not null unique check. For unique, if I go with the student name as unique, so why don't I put like constraint unique and constraint name student name unique, right? And then constraint unique, it will run really, no problem. But if I put same, it will fail because I am looking for student name unique. It's failing because it's already exist and we have created the rule that the value inside the name it should be unique. So it cannot be this one. But can it be this one? Answer is yes. Because this and this and is completely different. But I'm not concerned about this one. Yep, it is Robert and Nathan. But if I put like this and then put the text as name, will it work? Answer is no. That means if I have to define a single column using unique, we can simply define it here. But if we need to define more than one, like one or more than one name, it will execute properly. Yep. And age as well. Yep. But this is something I can't do it if I am writing it alongside this one. So I think it's better if I put all the constraint apart from not null at the bottom with the proper naming. So in case it failed or I want to create a mashup of multiple columns, I can do it. I think in the check statement also I cannot do this thing. Check age. But can I have the same name? It gonna follow. Yep, already exists. Now it write it down. B for bottom, okay? And now it execute. It does execute. Now let me write one more here and this one. It cannot be inside the check, but let me check. Name is not null, right? I'm putting this thing. Now it does pass. It does pass. But can it take this multiple value inside here or not? It is taking. If I create a combination of multiple columns in the check, so why can't I create a multiple unique like this here? Unique. Okay. Okay. Hmm. It does make sense to me, but let's check. It will fail. Yeah. Not me. So if I am defining a constraint to one single column as unique, I can simply write directly name text not null, and I think I can simply write as unique as a keyword, and it does follow like not. But if I have to define for multiple column, then I cannot define in this same format because I am writing to check a combination of columns as unique, not on an individual value. Here, but but for check, I did allow for multiple columns. Either you don't do it for any of them or you do it for both of them, right? This doesn't make sense to me. If this is allowed, then why constrained student name age are unique, and then unique then name. I just want to check before I move to this one. It is working. This structure is working. Then I will check for multiple. It failed. Okay, one second. It pass exactly. It is not even allowing that logic of unique as a function. It allow unique as an your keyword. But here they allowed it as a function. So check. Why is not even allowed this one unique? Is it possible? Is not all unique? It is not. So rule is simple. Don't use it here, but you can use it. So for a column, you can define not null as a keyword and unique as a keyword. Plus, if you want to define a combination of column as unique, then you have to write as a function in the bottom. You cannot put it together with the column. For the check is a combination you can put with this one, but you can also put it here as a new column. Why? Why this color very unique? Adding a unique constraint will automatically create a unique B-tree index on the column or group of columns listed in the constraint. A uniqueness restriction covering only some row cannot be written as unique constraint, but it is possible to enforce such a restriction by creating a unique partial index. Unique partial is in general unique constraint, a uniqueness restriction covering only some row cannot be written as a unique constraint, but it is possible to enforce such a restriction by creating a partial index. Okay. In general, a unique constraint is violated if there is more than one row in the table where value of all the columns included in the constraint are equal. By default, two null values are not considered equal in comparison because emptiness cannot be compared with the emptiness. That means null compared with the null cannot be compared. So both are both nulls because one air. So there's a two boxes with the air. One air is air, second is air, but they are not the same air. It's same like one air is from America, one air is from Europe. Both are air, but they are not the same air. So same similarly, the emptiness in both the in entity are not the same emptiness. It can be different. Let's take an example. If I have a record of professor where one of the information that I am gathering is a phone number, so it can be two ways. It can be the first one. The person does not have phone number, that's why it was empty. Second one is phone this get destroyed, that's why it's empty. So the reason for emptiness may differ from one another. You can remember it by that case. That is the reason the emptiness, empty value that we hold does signify different region, and it's possible to have a different reason. That's why two null values, empty values cannot be same. Just for understanding. That means a unique value column or combination of column can have unique values, plus they can have one or more columns with the unique more and one or more entities with the unique columns null. And that's where it can create issues. Despite the fact that it create a unique B tree to increase the searching, but that's a problem. You can handle it by creating again the logic that unique not null. So you can create unique not null not distinct. What does that mean? Why can't I simply create as here as where it is not null unique text, right? So let's remove this condition. Right now emptiness is allowed in the name. Perfect. And I'm putting as in I created one more H, and this one I'm not creating this one. Okay. So if I run it, it can execute properly. But now there's one third student that came in, and then is a fourth student. We have different ID, whom address was different. 4, 3, 2, 1, right? And instead of robot, let's keep it null. Let's keep it null. So Nitin, robot, null. I can still expect these are unique values, right? It have a null, then it had robot. At least one column has a null, so I can still identify this. But what happened? Home 3 null value violate the constrained student age check. Constraint age. Oh, see here. I put that constraint that name is not null. Hey, 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 hey. That means I cannot have a null value into it. I am by default forcing it to give some values. But suppose I don't write this condition here. See, Robert and Nathan is unique, but the problem with the null, they are also unique in their respective. Because I told you, the reason the information about this entity is null for the name can have different reasons possible, right? That means this emptiness represent a different reason why it was empty, why it is kept empty. That means they are unique to themselves, and that's why they cannot be segregated based on that one. But what will happen if I have this one? I have one more person robot with age of 32, home address as 23, and the ID is working on the fifth university. Now it already exists. That's why it cannot be done. So with the unique key, the problem is like it allow the existence of null as the value or emptiness as a value. And the problem is like each emptiness is unique in itself because it can represent possibly the different reason why it is empty. And that is the reason it is considered unique in oneself. So in a table, if the column is unique, it still can have null values. One and more record can have the null values in the defined unique columns. That means you cannot use it to create that unique B index or B tree index to improve the search. because the chances is few of the records might have null as a value into it. So it means that to create it very specific that all the values in this one is unique. So we need to constrain or filter out the record with a null value. So we need to put it here that name, which will hold the data as text in nature, cannot cannot anyone as entity is putting his people cannot be null, and then it can be unique. Now if run it, it will fail again on this too, and if I remove this too, it will again fail because now we have empty of this one. Then if I remove this one, then it should pass. Now you see that. Now what we are trying to force is we created the logic where the the name will be unique plus emptiness is not allowed. That means all the value that I'm gonna insert in this column, in the this table or column, will have completely different value for each record. So it's going to act as a key that can define one key, one row. This is the logic, one key, one row. But for the uniqueness, there is a possibility of null. So one key, multiple column it can represent. One key can be present in multiple column, that is null in the uniqueness. So it cannot give that feature of identify one record with one value, right? And we can convert this into one to many to one to one using not null constraint, or we can put not null constraint. Then it can act as one value, one record, one value, one record. And that's where this unique term get converted into primary key. Before we move, you remember what we are doing? We are always trying to add home and then the university ID as a home address. So what this address at the moment is doing, it is trying to add two things. One is home, second one is university IDs together. That means one is a static value, one is from another column, and we are doing is attachment. So we are not receiving it from somewhere, we are just driving it. That means we can convert this address into a column, derivative column or generated column. So we can simply generate the value. So we will use generated, right? And generated can be done using two ways. One is by default, if we are putting null, it will automatically put the value, or in case, so two things. One is user precedence, second is uh code precedence. So what I want a user precedence. If user give it, then take it. If not, then we will drive the value. So this way the code will become more flexible. So by default, by default, so that means if user is providing, it will take the value. If not, the default value. You remember default. Default to this, default this. So default generated generated then by default as we need to define as how we're going to define we're going to define as home plus this one university ID. Is it this one or concat? I don't know, but this is the logic I'm putting. Okay, so this is not the one. I think it should be concat. Uh, concat, concat, h comma this or concat dot. I need to check, dude. PostgreSQL concat concat. Uh, how to use concat in Postgres? Okay, we can use this one or concat. And simply write it. PostgreSQL concat. cat example. So concat and then okay, what we did concat. Oh, we were using dot. Dot is for referencing. If you remember, we are doing dot. This is referencing. That means go into public and whatever is present into this schema, search for the table student. So this is referencing. Here we need to use comma. Concat. Oh, so this one outside. So we're gonna replace this with this, then this. Uh, concat. Spell is right or right? Concat. Ah, concat. I think it should be str string. So I want to concat who with a column university ID as integer using n column address using generated by default. So I have user precedence con concat whom then university ID. That's something I want to do, right? So generate varchar. I text always default by cast as a string. This is the one. So right now I don't remember much, so that's why I'm just hitting a trial. Let's go, let's go. I think that string is for Python if I'm not wrong. But what happened? University ID integer not well. And it failed. Text generated by default as it failed. Mm. So there is a syntax error. What is the syntax error here? So it shows there is a syntax error near home. Don't tell me it's double code issue. Just don't tell me this is the issue. This is not the issue. This is not the issue. Address text generated by default as concat. Syntax error at or near concat. Always generated by always. Always also fail. Okay. Generated always as. I thought it should work, but again, it's not working, dude. It's not working. I think I should use this one. Generated as dude. Contact cast university ID. Is it possible what I'm thinking? Don't tell me it's possible. Because it won't make any sense to me if it does. No, I thought like putting university ID on top will give me some, but I think the syntax. Let's see here. I am getting syntax error. Dude, why this cola valley, dude? And the so no gender is required. Stored. Really? Generated column cannot reference another column. The Postgres does not allow generated column to refer other columns in the same table. How is that possible? Because the expression to generated. I was using a gender column is by default virtual kind. Insert a generated column cannot be written to directly in insert a number command. A value cannot be specified for a generated column, but the keyword default may be specified. Consider the difference between column with default and generated column. Column default is evaluated once when the row is inserted. If no other values was provided, the generated column is updated whenever the row change and cannot be overwritten. A column default may not refer to other columns of the table. A generated expression would normally do so. A column default can use violate function. Dude, it does take it because I did that thing. Default by and I think let's ask ChatGPT. 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 That's why AI love AI. Dude, sign up with the Google. Before I do that, let me switch to web. See my face. Then let me do this. Why I'm doing this right now? It doesn't make sense. How come you do me? Continuing, see. I think no thanks. Let it ground. Why am I doing this? I want to go to ChatGPT. ChatGPT. Yep, I'm here. Let me switch it back. Da, 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 da. Okay, so why generated column is not working for me? New generated column is failing because the syntax is incorrect for Postgres. Generated default by as is invalid syntax in this one. Column generated always as by dude generated by I used it. I used it. I used it, dude. I used it. Even this should be here generated column. Oh, oh, I got it. 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 So for identity, it has generated always, and then for identity, it has generated uh generated default by default. It makes sense to me. But if when I have to generate a column, then I have to use always. Okay. Okay, this is new. I love it. So even if it's always, but it is failed, right? Always name and address. Fast as this one. Good. Again failed. Why this color very color? So and we need to use stored as well. I guess it's stored. Ah, okay. Let's see if it does work. Home text store. Cannot insert. Okay. Ah, it changed. Cannot insert a non-default. Okay. So now I will put it as default. And I will put here as default. Okay. Because I'm generating. Ah, it does work. But I can add as one more thing here. I can put it space. Okay. But I want to check if it work for double quotes as well. And I should work. No, it doesn't. So for string, it take only single quotes. Perfect. Now if I remove store, will it still take it? It is, it is, it is. It indeed takes it. So I want to ask what happened if I use stored and nothing or remove it on the generated So in PostgreSQL store is a mandatory for generated column. Okay, I have to do it. I have to do it. So this is the first question that I want to ask. The second question I want to ask is,
Hey, how's it going? I'm looking forward to work. Hi there. I just want to share how thrilled I am. Hello. It's lovely to. Hey, it's great to meet you. Hey, ready to hit the ground running. Hey there. Got a really great feeling about us teaming up. How can I?
What else? If that's the case, syntax error. So why generated by default is allowed for and the identity column that I want to know, want to know, want to know. Okay, I learned something. I rectify my mistake. Yay! Oh, I have less battery left, so can you put it on charge? This is here. I don't need this one, but I need this thing. Hmm? What? What? I thought like it's a reverse. So let me grab the right one. Let me grab the right one. Uh, all I know is it's bigger than how it looks. Okay, so this is on charge. Okay, it's pretty cool. Oh, dude. Is anyone here? Nobody here. What should we do? Oh God, are you? Dude, my ears, because of my hair, it is itching. Okay, so I'm pretty much understood what exactly happened. Okay, so we are good on constraints. So we are. I think any constraint is done, and we are able to use the generated derived column value. So we are able to do that. We are able to use it without any store right here. Oh, what happened, dude? This is allowed. Understood. It also does. So I need to ask. It says it's error in the structure. Then why? This is working for me. This is working for me. Okay, so far how far we are? So far, how far? Mhm. Right break. Your code is working. No, I mean without stored word logic still executed. So why this happened? Postgre only supports stored generated column. It does not support virtual generated column, unlike MySQL. So then implicitly treated it as a stored. Okay, so not recommended. We have it makes sense, but uh, how virtual work virtual works, as I now store will store the value as it is, and if I don't do it in my SQL, won't it be like view? Great question. Stored as virtual explained. A value physically saved in like yes, no. Recalculated every time. Now, yes. Take up stored special no. Available in Postgres, yes. Virtual is no. Available in SQL, yes, yes. Sure. So virtual. So this value of address is not saved anywhere on the disk. Every time you run select a statement from the student, you will calculate it on the fly. It behave like formula in Excel and then okay. Why does it use it's not execute this same core concept. Nothing's stored nothing. Okay. Okay. Then for stored values for the generated column, how they get re e evaluated one of the parameter of column. Great question, I know. Store generate column automatically. When you column that a generated column depend on Postgres automatically calculated and updated. Ah, ah, ah. Uh, uh, uh. So virtual column value will have as select what is stored will be updated as depends. Yes, yeah. Ah, oh, okay. Gotcha. Gotcha. But Postgres doesn't have virtual, it have on a store. That's a unique one. Anyways, let's keep. So primary key constraint indicate that a column or group of column can be used as a unique identifier for a row in the table. This required that the value be both unique and not null. Exactly. That's what I was talking about. Unique work well if the element or the combination of the columns have values. If it is empty, more than one, go and go. And the problem with the null, you have to take it separate. The primary key is nothing but a, a column or group of column which have unique values and not null. The not null is unique in itself, so multiple not null is unique. They are unique. So column can convert it into from not unique to not unique to primary key, just add not null as a constraint to that column or the group of columns. But, but oh, dude. Hmm. Individually you need to apply because the problem is if you take two column as a primary key, let me explain you. Well, this is really interesting now. I understood one thing that every null is unique. Okay, so in a if two records are there for entity E1 and E2, which belong to the same table, that means they are similar entities. So they won't be so the number of attribute both have is two. Okay, first one is the name. Suppose they have the name N. It also have the name N. And second one was supposed to be ID, but both does not have ID because they have yet to get enroll or get into the organization. They are in the phase of enrollment. Okay, they are in the phase of onboarding. So right now they are not given any ID. So it's null. From the even E2 perspective, they are unique, right? They are different people. They are the unique entities. But from the information that is provided, that is name and ID and null from E1 and E2 is N and null. This is same, right? Null it should be same, but this null and this null are unique in their own senses or in themselves because this null be possible that the onboarding process is going on. So that's why it's not given this ID. He has to initiate or he need to start the process. He's not even like given the ID right now. They are constructed that offer letter is released. He accepted it. Now we are creating entry. So that's why this null. So both null represent different states. So that's why at given point of time, if a column or the attribute of two similar entities is null, they are not same null. They are different null. So every null is unique in itself. So that is even equals to E2 answer is no because both of null are unique despite the fact they have the same name. Okay. So if you do unique distinct name an ID, it should give me both and null and null. But does it technically should do, dude? Technically should do. But now I feel like it won't do. Sometimes it's really confusing. Let's run it. So I will top table if exists employees, right? And I will add name as text and I will put a constant that it should not be not null. It should have some values. The ID, it can be null based on the onboarding, but let's consider it as integer, right? Now I will insert into uh, employees values because I'm taking both the columns. I'm not specify the column order or detail because I'm going to keep the order same. So let's put it name as and capital and then null. And I can also insert one more entity like this, keeping it same. Now, if I run select asterisk from employees, oh, it should be create table and table name employees. Okay, see, I got two entries and it does make sense to me. But if I write select distinct of all the record from all the columns for the entities from employees. Now let's check. It is giving me one. Now, why it is not considered as unique? It's confusing at times. It's not considered as unique null values when I'm taking distinct, but it become unique when I'm comparing them. So that means comparison between nulls is not possible. Emptiness with something emptiness is not possible, and that's why it bypass it. Okay, wait. So primary key. So you can write unique not null or not null unique whatever, or you can simply replace this with the primary key. So primary key is nothing is equivalent to column or group of column not null unique key. But now with this logic, what I was thinking, should I? So if there is a so my logic was to I was thinking like this. Yeah. So if it is only one column that I'm considering as unique, so I can simply write not null and unique, and it will suffice my condition to make it a primary key. One value, one record can fetch me. But suppose I'm taking two column as unique, right? Where I was taking it initially. Now there's a possibility of chances that both have the value. One have a value and one doesn't, then this and this, and then both is null. Possible, right? In that case, how my primary key is defined? Primary key means one ID, one record, right? That's my logic for primary key to work. If that's the case, should I add a primary key on individual or a group of individuals? And what is primary key? Primary key is not null, value should not be null, and it should be unique. So if I'm taking a unique, that means it can be AB, A0, 0B, 00. The problem is with the combination of both. That means not null. So I need to check as a group, they are both not null. Because when I try to put the distinct, OB becomes same, right? As I saw you earlier, and null, and null. When I did the distinct, it gave me only one value. It is not taking them differently. That means I don't need to drop a record if any one of the entity that I'm taking as a unique combination is null. I need to take out the record which have all the null in the unique column I'm taking it for consideration. Means I need to drop this one. If that's the case, how I need to define. So my question will be, if I have to define a primary key using unique and not null for more than for two columns, how I'm going to do that? That's my question. So firstly, I need to define a constraint unique to the table, then unique, and it's gonna come as my function. I will put both the column 1 and column 2, and I need to make sure at a given a point of time that both are not null when I'm picking, right? That only is considered, and that means I need to one more constraint for null primary key, that is check column 1 not is not null and column 2 is not, because null A and A null Both are different values. Okay, if I put this thing, is gonna give me this value. Now these two are same. If they are different, then I need to drop it for even this individual null in a combination. These are same that I divide it with distinct, right? With the distinct, I show that if you put like this, they're gonna create a single one. It will give you only one record, null and a. That's why in a unique, this particular won't be allowed once this is inserted. Once this is inserted, another a and MP won't be allowed. But the problem with this one, this is together null null. This is null null. Then why this is allowed? Because in comparison null to null it failed. Oh dude, this is this is literally havoc, havoc, havoc. So null to null comparison failed, but when I do the this thing, it becomes one. So how it is it? So thing is, I need to understand the core concept of this too. Comparison and this. Comparison compare values. So like A is bigger than A is less than B. It is comparing some measurements and values. And both the null are empty values. That means it cannot be compared at any given point of time. Distinct represent values. What exactly it represent? Distinct means give me the distinct value or the representation of the values, right? This represent the same thing, that is null or emptiness. That's why distinct of null value give me only one. So comparison is not possible because they don't hold any values that can be compared with one another. But both represent the same, that is emptiness. So distinct become one, but when we compare, it failed. That's why it bypassed the check. Mm. So this and this will be allowed, but this and this allowed. This this is allowed because when I compare these two, they are different in terms of value because null cannot be compared, right? Let's do this. Why I'm wasting my time? Simply do it. Okay. Constraints. Constraint. Employees underscore unique. Okay. And I will get unique, and I'm putting two unique. First one is uh name. Second one is ID. I'm keeping this together. One is this one. Second, I'm putting the same. Third one, I'm putting as and null is allowed. Third one, I'm putting as null and 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 this one, and I'm putting two more, both as null, null, and oh, I'm putting it at text. Keep it at text. But okay, I put that as a unique. So one. So what happened when I'm putting it as null? One, two, three, four, five, six, but only three come. Okay, because that represent value, but when I'm doing only one name as this one, unique. It failed here, but if I did this one, it passes. And now why I'm putting this thing right now. All six are coming because ah, dudes, all six are coming. All six are coming. Again, null to null comparison is unique. But when I was doing individual name, it failed because I was there. Insert enter. System. Okay, because of this one, right? So what about this one? And what about this one? And putting it. All the four is coming because null, 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 null. What's this behavior? All six is coming because of null comparison. This is different. Because it cannot be compared. So automatically it bypass. Null cannot be compared. Never paid. But when I test, testing is label. String combination. It doesn't value it. Give me combination. Okay, man. Compare the values. Null doesn't have a value. So. Okay. Makes sense. So this should be unique values. Then how to make a primary key output? That means I need to drop even the every record that have the null values. I'm going to create. Uh, oh, this is 2 hours. I need to drop. Still not able to complete the things. My God. So column data type not null unique method when using a primary key, but I don't want to use a primary key. Method to is not null, and then I was right. Individually, you need to block not null, not like a combination of this one, because seven null and seven null both are different values, right? Combination null, but those two is different, and if they are different, but in primary key, this value represents two different values. One to many, because that's one key. Makes sense to me. Okay, primary key is also done. Getting a primary key will automatically create a unique B tree index on the column or group of column listed in the primary key and will enforce column to be marked not null. A columns, okay. A table can have at most one primary key. That means you can have multiple unique key, but only one primary key. There can be any number of the unique constraint which combined with not null constraint are functionally almost the same thing, but only one can be identified as a primary key. Okay, almost the same. Not null and combined with not null functions functionally almost the same thing, but only one can be identified as a primary key. Relational database theory dictates that every table must have a primary key. The rules rule is not enforced by PostgreSQL, but it is usually the best to follow it. Okay, makes sense. Primary key are useful both for documentation purpose and for the client application. For example, GUI application that follow modifying row value probably need to know primary key of the table to be able to identify row uniquely. There are always various way in which a database system make use of primary key. If one has been declared, for example, primary key defines the default target columns of the foreign key referencing the table. So foreign key. A foreign key constraint specifies that the value in a column or a group of column must match with the value appearing in some rows of another table. We must say is maintain a referential integrity between the two tables. When there is a hierarchical or hierarchy maintained between two data sets. So the biggest example and the easiest example is to understand that every student has a professor that he get tutelaged from, right? So that means a student cannot exist without a professor. A professor can exist without the student, right? That means in my student table, there should be one ID called professor ID or the supervisor ID. That should be present in this one. Okay. That means if ID is not there and a student here with that ID, there's a problem with this one. It's called referential integrity. That means when a table is dependent on another table for a reference, it's called referential and integrity, and this is defined using primary and your foreign key. Create a table product. This the primary key text. This one. Let also assume you have a stable storing order for those product. We want to ensure that order table only contain order of the product that actually exists. So we define the foreign key. Obviously, that means primary and foreign key relationship come into picture when you know that the values or the entity in this column cannot exist without this table. That's why you create one constraint that if you insert a record in this one, if you try to update any record in this one, they should have one corresponding record in this one. So that's why this column will become primary key, this column will become a referential key, and they will together become primary and foreign key relationship. This is a constraint we are putting, right? So primary key constraint is have one value, one record to identify. Foreign key become one primary key, and here one primary key, one record here. There should be one value that should be present in this table. for that corresponding column. So how it is defined, again, it can be defined in two ways, either alongside the column name and the column data type, or you can separately do that. So you can write constraint name, and the keyword that we use it, like for example, there we use the unique, right? Here you can write it reference, but whom you're referencing, that table and table name. So you're referencing to the table product, and you're referencing to column product okay, number or whatever it is. Here, integer references, or you can take it out from here, references, then do that. Or you can write it foreign constraint name, foreign key, when you have to define more than one. Okay. Here, make sure if you have only you have see for the check you can do multiple, but if you have one constraint, you can simply put alongside the column. If you have more than one, simply take it down. Yeah, that can be there, but I think for more visibility, I think all the constraints should be put down here. You can simply write one comment, like from a constraint, and then start writing constraints. Foreign key on B and C references other tables C1 and C2. That means the combination of B and C should match one C1 and C2, and C1 and C2 should be a primary key in this one, in this table. Of course, the number of type of constraint column. This is a foreign key. This one and references this one. So the logic is simple: foreign key and then key name. And here we just start with the references because this itself act as all this foreign key and this one. So you can write constraint name, foreign key, brackets, whatever the column from this table, then references to whom it references, the table and the column name. Of course, the number and the type of the constraint column need to be matched with the number and the type of the reference column. Obviously, if you're referencing one column, it's gonna be both side one. If two, it's gonna be two. It's gonna be same number. Sometimes it is useful for the other table of the foreign key constraint to be same table. This is called referential foreign key. Okay. So they are basically referencing themselves. This is possible, dude. So it's like, for example, if you want rows of a table to represent nodes of a tree structure, and okay, so with a table I can do the noding. Oh, makes sense, dude. This is really interesting. I want to try this one. A top level node would have zero null parent, while non-null parent and entries would be constrained to a referential valid node. Makes sense. It does make sense. It does make sense. Oh my God. So this way you can define a manager and the colleague relationship. So all the records are employees, okay? But that referential integrity will define you which one is references to the manager. And you can do it with the same one because this table belongs. Let me show you. This is really interesting. So suppose this is really interesting. This is an example of using the same. So this is a table employee. In the employee table, there's a possible that you are employee and there can be a manager for you. Manager. Okay, this is your manager. How to know who is your manager? Simply, and you can create one table where you take the employee information. Okay, then you create a self-referencing. You create self-referencing by uh, constraint, constraint name manager, my manager. That would be really fun. Then foreign key because it's a foreign key. Then the column name that is employee ID, whatever it is. uh, employee ID become your no manager ID become your foreign key. This is the manager ID. That gonna search for the IDs or references to the same employees table, and here ID, it will be employee ID. So if a new person is coming, he should have a employee ID, and then he should have a manager ID. So if I need now, what I have to do, if somebody want that you give me all the record of employee and the all the information about his manager in one place, now you have to do a self join, that A to A, inner join your from A1 and A2. Suppose from A1 you get the manager ID because that's about you, and then you search for A2 dot employee ID, and then you select A1 detail, and then you select A2 detail. From A1 you get the employee ID, and here one of the attributes that I have is manager ID that you search from here. You are done and dusted. So this can be done. That means it should have a foreign key. But does having foreign key make sense here? Yes. Foreign key can be null. But the problem is like foreign key can be null. Answer should be no. That means if somebody is coming in, they definitely should have a manager. Rather manager, I think your mentor will be right thing to say. Sometimes it is useful other table to foreign key on the sub-reference table. But top level not take a null but entity but constraint valid row to the table. Okay. Its parent ID is null. Its parent ID is null. It's interesting. Like now you have again the same table, all the detail. Then you have manager ID. I want you to get me all the records in such a fashion from your employee ID. I give you employee ID. You give me information from his manager M1, then his manager M2, then his manager M3, till the point there is no manager. So you have to recur again and again and again and again. So if I take this one, employee ID this one, and I take this one, so I have to do recursive CE. Oh, I understood this one. Ah, dude, this is fun. Recursive CTE, where I will make a loop until certain condition is formed. So select employee detail, okay, where employee ID equals to this one. That's the first value I will get. This is the one. And now pass, I will check one condition. If manager ID is not null, that means if it's a false, that means a null, that means this is the result, this one. If not, what it's gonna do, it will convert employee ID equals to into manager ID into employee ID, and then go back here and keep on storing the value. I will get all this one until last one. And once the manager is null, it will break and then understood. So it should be like select star employee ID. Okay. I will get all the record for the employee ID. Then I will insert into a table, right? Then what I will do, once it's inserted, I will check if employee ID, sorry, manager ID is null, I will break. And if null, then I will return this table B. This is table A, table B. Return table B. And I will end my finish my this one. But if it's not null, that means there is a manager that exist on and over it. Then what I am going to do, I will simply make manager ID equals to employee ID and start doing this one. Recursive. That means I need to apply a for loop or recursive CT, something. And what happened with this logic, until unless I receive the employee ID whose manager ID is null, it will keep on repeating. And this table, the table that I created B, will keep on inserting record. But one thing I will do when I will keep the record inserted, I will put one ID or timestamp. I will put an ID. And reason is very simple. That means it's the first record, second record, third, fourth, fifth, and sixth. Because the problem with Postgre and SQL is like they don't store the rows based on the insertion. So I need to create some key that will enable me to know what was the hierarchy or timestamp, whatever you feel like you can increase or short them in increasing or decreasing order. This will make a lot of sense to me. Sometimes way too many. So, okay, so that's a recursive city. If that's the case, it's fun, dude. It's really fun. It's really fun. It's really fun. But this was question asked to ask like 5 years back. I was able to answer it, but not in this manner. But I was able to answer. But that guy literally helped me. Like, he appreciated my method because I was like new, like 2 and 3 years experience. And that time, I don't think there was much exposure to a lot of resources, and I did pretty good job. Half a year, like half a decade or 6 years back. But now it's more clear to me. Like this can be a proper structure. But here, I think referential integrity. Should I put it or not? I need to ask. Like for SQL, can a foreign key have null value? This is not a primary key. It can have. It can have, dude. It can have. But if it doesn't, it means it have a value, then definitely it should match with the primary key of another table. That's the logic. A null in the foreign key means no relationship not assigned yet. It does not violate the foreign key constraint. That was I was talking about. Yes, it does. It does because it's not a primary key. It means if it's null, that means it's an empty value. It's blank. So there's no relationship. It cannot be compared. Okay, null cannot be compared. So it bypass that thing. One thing I need to understand, if null is being compared in any case is empty, it cannot be compared, so it bypass that one as a true statement or is okay, it's not failure. But if it has a value, that means it should exist in the parent table in the corresponding primary key. Okay, so primary key and foreign key relationship. Yep. Another one for foreign key, foreign foreign key. Does the parent should have primary key which on the columns on which I am in full sync this logic. Parent column must be either primary key or unique. It does not have to be strictly primary key. It just need to be uniquely identified. But what about the null then? Oh, okay. It cannot be compared, so it will bypass. So it not be considered. It will be compared with this. Okay. So parent column primary key unique will not be allowed at all. Okay. So for a foreign key relationship, the parent table can be either primary key or unique, but it has to be either of them. Boom. Interesting. That's more interesting than I thought. Dude, only 2 minutes more. I over lived this thing. Did I not? Did anyone join? Nobody joined. Why this collaborating? And D. I want to check, dude. Did it create multiple streams? Live. No. Nobody joined me like you do. Okay, so leave it. I need to finish this one. On do. Okay. A top level node would have null parent ID while non-null primary ID entries would be constrained to reference valid row of the table. Key constraint must have the same table. Self-referencing. Okay. A top level node have null. Table can have more than one primary key constraint. This is used to implement many-to-many relationship between table. Say you have a table about a product and an order, but now you want to allow one order to contain possibly many products. That's true. One order can have multiple products. So it's going to be combination of product ID and you can use the structure product order and product order an item. So now you segregate the things you created. One product is the product. This is the order. One product can have in multiple orders. One to many. Many to many is like then one. So it manually. Notice that the primary key overlap the foreign key in the last table. We know that the foreign key disallow creation of orders that do not relate to any product. But what if product is removed from an order is created that reference it? SQL allow you to handle that as well. Intuitively, we have the option disallowing deleting a referential product, deleting the order as well, and something else. To illustrate, let's implement the following policy on many-to-many relationship example. When someone wanted to remove a product, one-to-many, many-to-many product that is still referenced by order, we disown it if someone remove an order item are removed as well. Okay, so this is the order item. Primary key we are putting on this thing. Okay, this to become a primary key combination, and this references to product, and this references to order. If product is deleted or order is deleted, it will be deleted. But what does that cascade means? Cascade means if order is deleted, all the order IDs on delete restrict. What it means? Default on delete action is on delete no action. On delete action is on delete no action. This does not need to be specified. This means that the deletion in the referenced table is allowed to processed, but the foreign key constraint is still required to be satisfied. So this operation will usually result in an error, but checking of foreign key constraint can also be deferred to later in the transaction not covered in this chapter. In that case, then the no action setting would allow other commands to fix the situation before the constraint check is checked. For example, by inserting another suitable row into reference table by deleting the now dangling row from the reference table. Restrict is a stricter setting when no action it prevent deletion of referenced row. Restrict does not allow the check to differ until later in the transaction cascade. It specified that when a reference row is deleted, rows referencing it should be automatically deleted as well. There are two other options, set null or set default. Okay. No action, restrict, on delete, cascade. So no action. What is restrict? Set default or set null or set default. So nulls. These cause the referencing column in the referencing row be set null or the default values. Respective the reference row is deleted. Note that these do not excuse you from observing any constraint. For example, if an action specifies set default but the default value would not satisfy the foreign key constraint, the operation will fail. Okay. The appropriate choice of on delete action depends on what kind of object in the related table represent. When the referencing table represents something that is compound of what is represented by the reference table and cannot exist independently, then cascade could be appropriate. If two table represent independent object, then restrict or no action appropriate. It can live an action. That's true. For example, professor and student. Professor leaves it. This one does effect should have professor, but does not live without a professor. That means we need to flag it with something. Restrict or no action. So automatically it order delete, but product and order are different things, and so making a deletion of a product automatically causing the deletion of some order item could be considered problematic. So the action set null or set default could be appropriate if a foreign key relationship represent operation information. This one. Primary key tenant, user and tenant. Tenant ID, user, tenant. Houston. Great. Post. Tenant ID references tenant on the link cascade. Cascade. Post and user. Tenant. Good. Normally, a referencing row need not satisfy the update which is involved when referencing column is changed. Referenced column is changed or updated. The possible action are the same except that the column list cannot be specified for set default. In that case, cascade means that the updated value from reference within should be copied. This includes this is also noticeable difference between on demand, the determination, the default realistic the form allow the auto the update with distance prevent updating a reference to value that is distinct but compares or equal. For example, a thing normally a reference for it is a column unknown if match full decided. Dude, I think I overexhausted myself. I need to come and do this again. I know I took more time, and still modifying is not done. Tomorrow, I think this gonna complete, and then system column, deployed ID, the OID. Every table has a server system column that are implicitly defined by the system. Therefore, these names cannot be used as the name of the user-defined column. Note that you can really need to concern about this column. Just know this exists already. So let's see. Okay. This will be faster, dude. This will be faster. Tomorrow I will be able to complete both of them. Tomorrow definitely is gonna complete this and this. So where we are, roadmap. Tomorrow is 7th. Yeah, tomorrow I think we will be able to complete. No, we won't be able to complete. There is insert update. Yep. Oh, no. I think yes and no in both the scenario because select is just a select. We are already using it for a long time. It's just insert we are doing it for a long time. This is not a problem. The problem is data type is not even started. and insert update is left, modifying is left. Tomorrow, if this foreign key and this is done, then this is not. It hardly take 15 minutes or something. But after this, what? Privileges. Okay, this is not something we need to concern ourselves for time being. Pro security. Schemas. Nope. Inheritance. Nope. Table partition is something for later. Foreign data now. Other database object. Nope. Views. What I have to do is to data manipulation. So that hardly take an hour. Then data type. Data type also we're not gonna cover everything. We will cover only the basics. So it's not a big thing, dude. Integer, numeric, monetary type. Okay, so I think one more day max. That means tomorrow our target should be completing the this one, the foreign key, then your modification, constraint modification. There's no constraint here, right? No. Then your data type, then data manipulation, and select. I think within 2 days we will be able to finish. I know we are exceeding the time, but that's completely fine. Well, this because if I'm able to hold on this one, where clause and clause or clause order by limit, dude, these two can be combined into one. That's not a big deal. Distinct null handling, dude. Phase three can be done in a day, so I can borrow a day from this one, and this can be done in a day. A day. This can, but yep. Because I learn a lot, dude. I learn. Anyways, with this, I will wrap because nobody joined here. It was fun to learn here like this. Yep, nobody.